we have the function. So the following things are given. F of x, which is equal to x minus 2 by x minus 3. So wherein it is mapping set A to set B. And set A is made up of real numbers excluding 3. And set B is made up of real numbers excluding 1. So we have to check if it's 1, 1 and not 2. Justify your answer. Now, we'll start off with 1, 1. So we'll talk about let A comma B belong to set A, represent two arbitrary. What is that we are trying to do? Yes, we are trying to show that for two different input values, we have the same output value. So we are doing proof by contradiction, such that, what is that we are looking at? F of A is equal to F of B. Now, what is F of A? A minus 2 divided by A minus 3, which should be equal to B minus 2 divided by B minus 3. So we can see the same expression. Obviously, it will result in A is equal to B, but yeah, we need to show the calculation. A minus 2 times of B minus 3 is equal to B minus 2 times of A minus 3. Further, we have AB minus 3A minus 2B plus 6 is equal to AB minus 3B minus 2A plus 6. Quite a few things will get cancelled over here. And further rearranging, we'll get A is equal to B. So from this, we can infer that our assumption was wrong and we have the same input values, which is pointing to the single output value. So finally, we can tell F of x is 1, 1. So 1, 1 is quite simple. 1, 2 is also simple, just that okay. So we have a bit of complication over here. On to, just a second, guys. On to, okay, we'll start off with this way. Now, let A represent all the arbitrary elements in the codomain. Okay, next thing. Then f of x will be equal to A, right? Which can be rewritten as x minus 2 by x minus 3 is equal to A. Now, what is that we are trying to do? We are trying to get an expression for x in terms of A. So a bit of calculation over here, right? I just cross multiplied, and bit of rearranging. I have x minus ax is equal to 2 minus 3a. And if I take x common over here, I'll get 2 minus 3a, this entire expression divided by 1 minus a. Right? So this is the expression. So this expression looks okay, provided a is not equal to 1, which it is not. So a comes from your set B, right? This a comes from your set B. Is it not? Codomain is nothing but B. So it does not have 1, so this will not result in infinity. That's the first thing. Second thing is, we also have to look into the possibility that A, that is x, which belongs to set A, since it's not containing 3, we have to show that we don't need 3. So this is something that people miss out. So this step is to show x need not be equal to 3. Okay, how will we do that? Simple. We'll tell for x is equal to 3, what happens over here? Let's see. So 3 will be equal to 2 times of, or 2 minus 3a divided by 1 minus a. a bit of rearranging. What do we have? 3a minus 3 minus 3a is equal to 2 minus 3a. So this and this get cancelled and we get 3 is equal to 2. But what is 3 is equal to 2? A false statement. So from this, what can we tell? Since it's a false statement, we can clearly tell that x does not contain 3. So all in all, what can I write? Yes, we can just end up writing the following. As A belongs to B, that is A is not equal to 1, the expression x will result in values that are part of real number excluding 3, which is nothing but our set A, which is set A. And so what do we have? Therefore f of x is onto for f mapping from set A to set B. Right guys, so this is your conclusion. So generally people miss this out, so let's not do that. It's quite simple. We just take up value which is not part of your domain and show that yes, it is not part, we don't need it, and so we have the following answer. Okay guys, so please pause, have a look.